Using SOHCAHTOA to find side lengths. So recall the three trigonometry ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Remember that we find these sides from our diagram of a right angle triangle. So always across from the right angle is the hypotenuse. And then the opposite and adjacent sides will change depending on where their given angle is. So in this case, our angle is in E. So across from E is the opposite side. And right beside the angle E is the adjacent side. So the sine, cosine, and tangent ratios are used to find the measurement of side lengths and angles in a triangle. When you encounter a problem where you have the lengths of one side and at least one of, we call them acute angles in a right triangle, it is possible to use a trigonometry ratio to find the length of the third side. So we cannot use the right 90-degree angle in order to solve for any sort of missing side. We have to use one of the other two angles, and we call these acute angles because they are smaller than 90 degrees. So let's go through some examples. We want to find the length of AB. So this is the line segment AB, which can also be called C, because it's right across from the angle C, to the nearest tenth. So remember, that's rounding to one decimal place. So these are the three steps to solving for a missing side length. So the first thing we want to do is label the sides of your triangle relative to the angle. So always across from the right angle is the hypotenuse. The angle that's being given to us in this question is C, which is 37 degrees, and across from that angle is the opposite side, and the side right beside the angle is the adjacent side. So then we want to determine which trig ratio to use. So are we going to use sine, cosine, or tangent? And how we determine that is by looking at what we know from our diagram and what we're trying to find. We know the hypotenuse. We have the measurement of the hypotenuse of this triangle, and we're looking for the opposite side. We're trying to find the length of AB. So this is the side that we know, 11, and this is the side that we're trying to find, C. And those are the opposite and the hypotenuse. So if we think back to our trig ratios, remember that SOHCAHTOA, we have to think about which one of these uses opposite and hypotenuse. Well, the opposite and hypotenuse is using sine. So sine is opposite over hypotenuse. So we are going to find now, this is how we write this next step. So we're going to set up the equation with the unknown and solve. So we are trying to find the sine of angle C, which is the opposite over the hypotenuse. Well, the angle of C is 37 degrees. So the next step will be to just substitute in what we know from this triangle. So 37 degrees is angle C. The opposite side is our unknown. We're going to call that little c. And our hypotenuse is 11. Now here is where we're going to be introduced to how we can use our calculator to calculate this measurement, which is sine 37. So in our previous lesson, we looked at finding the sine of a number or the cosine of a number by figuring out what the two sides were and then dividing those numbers to give us our decimal number. But on your scientific calculators, you actually have a sine, a cosine, and a tangent button, and they're usually labeled as SIN, COS, or TAN. And so depending on how your calculator works, you might have to press the sine button first and then enter in your 3, 7, and then equals. Or sometimes you might have to enter in your 3, 7 first, and then press sign, and then equals. So you have to decide which one of these methods will work for your calculator. And sometimes calculators will want you to use brackets around the 37 as well. So you're going to have to figure out how your individual calculator works. If you have any questions about it, if you can't figure out how to work it, let me know and I can definitely walk you through that. So on my calculator, I have to enter in the sign button first, and then I enter in 37, and I press equals, and I get an answer of 0.6018 if I round to 4 decimal places. Remember, don't keep any more than 4. 4 is perfectly fine. And that's equal to C over 11. And now it becomes a solving equation question, which we've looked at in some previous units. So what we need to do is we need to isolate for our letter C. And we do that by doing the opposite of dividing by 11, which is multiplying by 11. So I want to multiply both sides of my equation by 11. So 11 times 0.6018 is equal to 6.6198. And my two 11s on the right-hand side will cancel each other out because 11 divided by 11 is 1. So I'm left with just C, or 1C. But I want to make sure that I keep this answer to 1 decimal place. So my final answer for C is going to be 6.6, and my measurement, so what I'm using as my unit, are centimeters. I know this can be a little bit tricky when we're first starting out, so let's do a couple of more examples. In the second example, I want to find the measurement of side TS, which is also the side little u. And the first thing I want to do is to label the sides of my triangle. Across from your right angle is your hypotenuse. Across from your given angle is the opposite side, and the side right beside the angle is the adjacent. Now we have to figure out what I'm trying to find. Well, I'm trying to find the adjacent side, and I know the hypotenuse. So if I think back to SOHCAHTOA, I look to see which one of these trig ratios uses adjacent and hypotenuse, and that ends up being the cosine. So I'm going to write the cosine of angle T is equal to the adjacent over the hypotenuse. So once we've identified the trig ratio that we're using, we're going to substitute in what we know and then solve for our own unknown value. So the cos of angle T, which is 22 degrees, is equal to my adjacent side, which is little u, over my hypotenuse side, which is 9.2. So from here, I want to use my calculator to figure out what the cos of 22 degrees is. So in my calculator, I press the cosine button first, and then I enter in 22 degrees, and I press equals, and I get a value of 0.9272 if I round to the nearest to 4 decimal places. And that's equal to u over 9.2. So I want to isolate for my letter u. So right now it's being divided by 9.2. The opposite of division is multiplication. So I want to multiply both sides of my equation by 9.2. This will get rid of my 9.2's on the right-hand side because 9.2 divided by 9.2 is 1. So I'm left with 1u, or just u. And then I want to take my 9.2 and multiply it by my 0.9272. And that gives me an answer of 8.5 if I round to 1 decimal place. That's what my question asked. And I look at my measurements and I'm measuring this in centimeters. So the length of side U is 8.5 centimeters. I know that this is probably a good number because it's smaller than my hypotenuse. So remember that your hypotenuse is always the longest side of your triangle, of your right angle triangle. So as long as your measurement is lower than that hypotenuse, then you know you've probably made a good decision in terms of your solution. Let's do one more example. In this example, we want to find the length of side DE. So this is that line segment right here, which is also called little f because it's the side across from angle F. And again, I want to round this to the nearest tenth, which is the same as 1 decimal place for my final answer. So first thing I want to do is label the sides of my triangle. Across from my right angle is my hypotenuse. Across from my given angle E is my opposite side, and beside angle E is my adjacent. Now I have to ask myself, what is it that I'm trying to find? Well, I'm trying to find the adjacent side. I'm trying to find side F, and I know my opposite side. So I have to, again, think back to my SOHCAHTOA. Which one of these trig ratios uses opposite and adjacent? And as I look here, I find that tan is the one that I need to use. So I'm finding the tan of my angle E, and that's equal to the opposite over my adjacent. So now I substitute in what I know. The tan of E is 9 degrees. My opposite side is 9, and my adjacent side is little f. At this point, what I want to do is I want to figure out what the tan of 9 degrees is. So I'm using my calculator to work that out, and I get an answer of 0.1584 if I round to 4 decimal places. And this is equal to 9 over f. Now, when your unknown value is in the bottom of your fraction, it's not as simple as just being able to multiply by a term. So in this case, I want you to think about, I can write my 0.1584 as a fraction if I place it over 1. So anytime you have a number, you can turn it into a fraction by putting it over 1. And now I want you to think about when we looked at solving for our unknown sides, when we looked at similar triangles and using the ratios of our sides to look for missing sides or missing information, I did something called cross multiplication, which is a strategy that some teachers don't like, but it is the most efficient method in order to make this work. Okay, you could go ahead and then multiply by f and then go ahead and divide again, but this is a method that just makes those steps a little bit more efficient. So what we're going to do is we're going to take our 0.1584 and we're multiplying it by f, and that's equal to 1 times 9. From here, I simplify what I have on my right-hand side. 1 times 9 is 9. And then I can take and divide by the coefficient in front of my variable, which is 0.1584, and I do that to both sides, so that they disappear on the left-hand side because this makes 1, so I'm left with 1f or just f. And then I take 9 and I divide by 0.1584, and I get an answer of 56. Sorry, 9 divided by 0.1584. Yes, So I get an answer of 56.8, and my units are centimeters. If you have any questions about this lesson, please reach out to me, send me a message on Teams or an email, or sign up for a virtual help session, and I will see you in the next lesson.